How does the interrupt vector table work for microcontrollers? Imagine your microcontroller as a busy city with many roads leading to different destinations. When an unexpected event happens, like a car needing to turn, the city needs a quick way to send that car to the right place. That's where the interrupt vector table comes in. It acts like a map that tells the microcontroller exactly where to go when an interrupt occurs. The interrupt vector table is a special list stored in the microcontroller's memory. Each entry in this list is called an interrupt vector. These vectors hold the addresses of the routines that handle specific events, called interrupt service routines. When an external device or internal event triggers an interrupt, the microcontroller uses the interrupt number to find the right address in this table. It then jumps directly to that location to handle the event immediately. In most microcontrollers, the table is placed at a fixed location in program memory. When an interrupt happens, the microcontroller's hardware looks up the corresponding vector in the table. It then loads the program counter with the address stored there. This process is very fast, allowing the microcontroller to respond quickly to events like a timer overflow or a data received on a communication port. Different microcontrollers use different methods to access the interrupt vector table. Some load the program counter directly with the address from the table, often with a jump instruction. Others fetch the address first, then load it into the program counter. In ARM Cortex and microcontrollers, the table begins with the initial stack pointer value, followed by the reset handler, and then other interrupt addresses. This table can be moved in memory if needed, using a special register called the vector table offset register. This flexibility is useful for switching between different firmware versions or applications. When an interrupt occurs, the microcontroller first saves its current state, like the program counter and status registers. It then disables further interrupts if necessary to prevent conflicts. Next, it jumps to the address in the vector table that corresponds to the event. After the interrupt service routine finishes, the microcontroller restores its previous state and continues executing where it left off. This system makes the microcontroller very responsive and reliable. It allows the device to handle multiple external signals and internal events efficiently. The structure of the interrupt vector table supports modular programming, so you can easily update or change how specific events are handled without affecting the rest of the system. Whether it's managing timers, communication interfaces, or sensors, understanding how the interrupt vector table works is key to designing effective embedded systems.